Diode power consumption. Why should we care? Basically, if a diode consumes too much power, it can overheat and get damaged. So in this video, we look at the design considerations to ensure that your diode doesn't blow up. Calculating diode power losses. This is really easy. The power is equal to the voltage across the diode multiplied by current. P is equal to V times I. Calculating the change in diode junction temperature. You can calculate how hot the internal silicon of a component gets using its thermal resistance. Change in temperature is equal to P times R theta Ja, where R theta Ja is the thermal resistance and has units of degrees Celsius per watt. You can find this thermal resistance in your diode's datasheet. To make sure that our diode doesn't blow up, we must not go above its specified temperature. This is also found in the datasheet. That's all the theory. So let's look at an example for a common 1N4001. The question we want to ask is, will our diode operate reliably when the forward voltage is 0.8 volts, the forward current is 250 milliamps, and the maximum ambient room temperature is 80 degrees Celsius? From the datasheet, we find a thermal resistance of 50 degrees Celsius per watt, and the rated maximum junction temperature is 150 degrees Celsius. Alright, we're going to fire through the solution really fast, so pay attention. Step 1, we'll calculate the power dissipation of the diode. P is equal to V times I, which is equal to 0.8 volts times 250 milliamps, which is equal to 200 milliwatts. Step 2, calculate the change in the junction temperature of the diode. Change in temperature is equal to the power times the thermal resistance, which is 0.2 watts, times 50 degrees Celsius per watt, which is equal to 25 degrees Celsius. Step 3, calculate the worst case diode junction temperature. This is equal to the ambient temperature plus the change in junction temperature from step 2, so 80 degrees plus 25 degrees Celsius, which is 105 degrees Celsius. Finally, step 4, compare the worst case temperature to the rated junction temperature. 105 degrees Celsius is less than 150 degrees Celsius, so yes, in this case, the diode thermal considerations are okay. That's all for power considerations. The following videos will be on diode applications.